And in 6.3, we're going to start graphing these square root functions that we've been dealing with. So just another one of our parent functions to introduce. This is the square root function. So the parent function is f of x equals the square root of x. Okay, so just a very simple square root functions. And then, you know, as soon as we start doing the transformations, we're going to shift it, left, right, up, down. We're going to stretch, compress, maybe flip it. So we've done this before, but starting off with just some basic facts about what the parent function looks like. Okay, domain. Here's an important part. Domain is not really a tricky one, but kind of unique here. This is the first time that our domain isn't all reals. Every other function that we've dealt with up until this point, we are allowed to plug in absolutely anything that we wanted. But this is a square root function now. We're only allowed to plug positive things into a square root. Otherwise, it comes out imaginary, and we can't graph imaginary things. Okay, so our domain is strictly values that are not negative. So only x values that are greater than or equal to 0. 0 is fine, so it's included because you can take the square root of 0. And then if you think about how a square root comes out, if you're just talking about the principal roots, that's the main one, you only get positive values out as well. So the range is just positive values of y. So all positive, and you'll see what that graph looks like once we actually plot it. Okay, intercepts. Intercepts, if you plug in 0 for y, like if we plug 0 in for y right here, we would end up with x equals 0. And if we plugged in 0 for x, we would end up with y equals 0. So that means that it all starts at the origin. Okay, it starts at the origin and then it goes from there. It's not defined for any negative values of x. We just talked about that. So that's why those values are excluded from the domain. So just positive values. And then end behavior. Let me show you what the graph looks like first so that hopefully the end behavior will make more sense. All right, so we're only dealing with positive and negative values of both x and y, so we don't need to include anything over here. So they both start at 0, 0. So if we plug in x equals 0, the square root of 0 is 0. And then if we plug in x equals 1, the square root of 1 is 1. And then the next perfect square root is 4. So plugging in 2 will give us a decimal, plugging in 3 will give us a decimal, plugging in 4, the square root of 4 is 2. Okay, and then it goes from there. Okay, so what the graph looks like, it starts at the origin, and then remember, there's no negative values of x, no negative values of y. So it just starts from here, and it's got this like very minor curve that grows really, really slowly from that point, because the next point would be 9, 3. You know, square root of 9 is 3, and then square root of 16 is 4, so it grows really, really slowly. So the end behavior, as x approaches 0, this is the end of the graph, it doesn't go off to the left. So as x approaches 0, the function approaches 0, and then it stays there. And then the other end behavior is as x approaches positive infinity, our function also approaches positive infinity. Very slowly, but it does. Okay, so remember, when we talk about transforming points, we need to know what the original points of the parent function were. So this is the origin right here. 0, 0 is one of our original points. This is the point 1, 1. Square root of 1 is 1. And then this is the point 4, 2. Square root of 4 is 2. Okay, so those are our 3 original points. So when we start doing the translations, the dilations, and the reflections, those are going to be the 3 original points that we always come back to. Okay, so let's talk about the domain and range of this function right here. All right, so domain and range are going to change as we shift our graph a little bit right here. So that x minus 2, we can go off the same transformation rules that we had in previous sections. So the important part of the domain is that we're only allowed to plug in positive things into the square root. So whatever you have under the square root, that always has to be greater than or equal to 0. So this time, instead of just an x under the square root being greater than or equal to 0, we have an x minus 2 under the square root, and that has to be greater than or equal to 0. So anytime you're looking just for the domain, you can take the part under the square root and make sure it's greater than or equal to 0. So here all we'd have to do is just add 2 to both sides, and we know that x is going to be greater than or equal to 2. So that's the domain. That's the domain. That's part 1. And that should make sense, because remember what an x minus 2 does is it moves everything 2 units to the right. So if the graph doesn't start until x equals 2, then x is greater than or equal to 2 should hopefully make sense. And then for the range, what you do is you plug that 2 back in and see what y value the graph will start off on. Okay, so plug the 2 in. So for the range, plug the x equals 2 in. So we want the function evaluated at 2. So square root of, so plug in 2 for x, and then minus 2. So that comes out to be 0. Okay, so our lowest y value is still 0, and then it's going to follow this shape from there. So the range will be any y value that is greater than or equal to 0. So take a look at the original domain and range. Any transformations that we have will also transform the domain and range. So this transformation says we move 2 units to the right, so that's why our domain went up 2 units. But it doesn't say anything about moving up or down, which is why our range did not change at all. Okay, let's look at our next examples. So now we're going to talk about what these transformations are going to do, how they're going to affect the 3 points that we have on our original graph. So same, and we were still seeing the A, the H, and the K. So these translations are still exactly the same. So just like we did with parabolas and with some other functions. So the horizontal translation has to do with the H. So the H is on the inside, and remember, the H always does the opposite of what it looks like it's going to do. So if you have an x minus h like that, it actually goes h units to the right. Okay, so if you're going h units to the right, what you're going to do is you're going to add h to the x values. That's how you transform your original points. And then if you have x plus h, again, you're doing the opposite of what it looks like it's going to do. So that actually takes you h units to the left. So if you're going to the left, you're going to take your x values and you're going to transform them by subtracting h from the x values. Sorry about that. Okay, our vertical translation is this value k right here. Because it's vertical and it's not inside with the x, it actually does exactly what it looks like it's going to do. So if you have a plus k on the outside, that goes k units up. And so you would add k to all the y values. Up and down affects y. And then if you have minus k, again, it does what it looks like it's going to do. So you would go k units down, meaning you would be subtracting k from all the y values. So left and right affects the x values, up and down affects the y values, and then the orientation and shape, that has to do with a. So it might get flipped upside down, it might get stretched or compressed. So there's a couple different things that you could do. So if a is less than 0, if that value out front is a negative, your graph is going to end up flipped upside down. And then if you have a large value of a, if it's like 2 or 3 or something like that, you're going to have a vertical stretch. And then if you have some sort of fraction, you know, like 1/2 or 1/3 or something, that's going to be a vertical compression on your graph. Okay, so all these things are vertical. So flipping upside down, that's a vertical change. Stretching and compressing vertically. So anything that's affecting the graph vertically affects the y value. Okay, so what you're going to do, no matter what is happening here, no matter what a is, you're going to multiply all the y values by a. So you can see all these different transformations that will happen to our original 3 points. So let me show you exactly what that looks like. So we've got our graphs right here. We're going to state the domain and range, but we're going to graph first. I think it'll be easier once the graph's in front of you to figure out what your domain and range should be. Okay, so we're going to start with your original 3 points. So I'm going to write O for original. So it always starts at the origin. Remember, there's nothing past the origin. So there's nothing to the left of the origin. It's always the starting point of your graph. Okay, and then we have the point 1, 1 and the point 4, 2. Okay, so let's transform them. Let's take a look at everything that's happening here. So start with the x values. Remember, the only thing that affects the x values is this like x minus 4. So x minus 4 means you're moving 4 units to the right. So you're going to add 4 to all your x values. Okay, so add 4 to your x values. Don't touch y yet. Add 4, add 4. And the y values, 2 different things can happen to the y values. So multiplying, so just a quick note, this would happen first. If you're doing a transformation, you would do that first, and then you would add or subtract anything from here. Okay, so first, we're going to multiply the y values by 3, and then we're going to add 2. Okay, so multiply by 3, you get 0. Add 2, you get 2. Multiply by 3, you get 3. Add 2, you get 5. And multiply by 3, you get 6. Add 2, you get 8. So we're going to plot these 3 points. Once we plot those 3 points, we'll have our graph. That'll be part of the answer, and then we're going to write down the domain and range. Okay, so we're going to scale this 2, 4, 6, 8, 10. Same thing with this. Scale 2, 4, 6, 8. Okay, so we've got the point 4, 2. So here's 4, 2. Now that's the starting point. You're not going to see anything to the left of that point. And then 5, 5, be like right there, kind of right in the middle of these scaled values. And then 8, 8 would be here. Okay, so this is the starting point. Remember, you're never going to see anything beyond that point. So go and make sure the graph is carrying some sort of a curve to it, like that. No arrow over here, because that's going to be your starting point. All right, so now let's state the domain and range. Okay, so domain and range is always going to be the possible x values. I'm sorry, domain is the possible x values. Range is the possible y values. Okay, so you basically just see where it starts. So the starting x value is 4. You don't have anything beyond that, and then it goes to the right. So it's all the x values that are greater than or equal to 4. And then the y values start at 2, and then they go up. So it's going to be greater than or equal to 2. Okay, so we've got our graph, we've got our domain and range. Let's repeat the process with this one. So same original points always for this section. And now let's transform them. So x values, x plus 5. This means you're going to go 5 units to the left, so you subtract 5 from the x values. So 0 minus 5, 1 minus 5, and 4 minus 5. So those are my new x values after I shift to the left. And then I have a is -1. Careful there, it's kind of blending with the square root. And then -6. So I'm going to take my y values, multiply them by -1, and then subtract 6. So 0 times -1 is 0. Minus 6. 1 times -1 is -1. Minus 6 is -7. And 2 times -1 is -2. Minus 6 is -8. So these are all totally negative values here. So when I go to graph this, I actually have all negative x values and all negative y values. Okay, so probably don't need to scale the x-axis, but we need to go all the way down to -8. So let's scale this. So -2. Okay, so we start at the point -5, -6. Remember, that is the starting point, so we won't have anything graphed beyond there. So here's -5, and then down at -6, right there. Starting point. -4, -7. So right there, there's -4, -7, and -1, -8 is right there. Okay, so this is the starting point. So plot nothing beyond that point. Start there, and then just follow the curve, and it goes off to the right, like that. Okay, so there's your graph. It's upside down because of this negative right there, so that's the first upside down one that I have. So that's going to change the domain and range a little bit. Okay, so possible x values, possible y values. My first x value, the starting point, is -5, and then it goes to the right. Okay, so to the right of -5 means greater than or equal to -5. And then y, my first y value is -6, and then it goes down from there. So going down is actually going to change my range to be less than or equal to, because it's anything below -6. Okay, so there's the graph, there's my domain and range. We're going to look at this one really quickly. It's like a little story problem. Okay, so we've got an object spinning in a circular path. The velocity is given in meters per second. Acceleration is given in meters per second squared. And so here's the function right here. You've given a velocity function in terms of acceleration. So we want to graph the function. All right, so we want to know what would be the centripetal acceleration. So we're going to graph and then answer a question here. So when we start with our original points, we're going to do a little something new here. Okay, so if we look at the original points, there's no plus or minus inside here, but there is multiplication. So this is actually something that we haven't seen yet. Remember, when something is in with the x, we always do the opposite of what it looks like we're going to do. Okay, so doing the opposite of multiplying by 2 would be dividing by 2. So we're going to divide the x values by 2. So that's still 0. That would come out as 1/2. And then dividing this by 2 would be 4. Okay, so now nothing affects y. There's no a, there's no k, so the y values stay the same. Okay, so we're going to plot those points. Here's 0, 0. And then if we do 1, 1, there's 1/2 1 right there. And then 2, 2. Be right there. So starting point and plot like that. So there's the graph. And then it says, what would be the centripetal acceleration with a velocity of 4 meters? So if we plug in 4 for the velocity, we'd have 4 equals the square root of 2a. And then we could solve for a. So start by squaring both sides to get rid of that square root. So 4 squared is 16. When I square the square root, cancels out, just leaving me with the 2a. And then I would divide both sides by 2. So I end up with a equals 8. And it says that's given in meters per second squared. So that would be the answer. And of course, that's the graph. All right, now the last thing that we are going to look at is our inequalities. Okay, so graph the following inequalities. We're going to start with our original 3 points, transform them, and then plots. Okay, so we have x minus 4, so that means I'm going to add 4 to my x values, so I'll start there, add 4, add 4, add 4, and then for my y values, I'm going to multiply by a -1 and then subtract 6. Okay, so that gives me -6, -7, and -8. Okay, so start just by plotting the points, and then I'll walk you through how an inequality is a little bit different. Okay, so I need all positive x values, all negative y values. So it'll look like this. Scale by 2. Okay, so we have 4, -6. So here's 4, -6. That's the starting point. 5, -7. And 8, -8, right there. Okay, so starting point, and then curve from there. But before I actually plot, pay attention to this. That is just a less than. So just a less than means I am going to have a dotted line, like that. Okay, and then the less than, this is actually pretty simple. Less than means 2 things. It means it's dashed, like I just did, but less than means below. So it means it's dashed, and I shade below. Now pay attention here, we will not ever go beyond that point. So it has kind of a vertical line drop down, because this is all outside the domain. So you can't graph there, you can't shade there, so make sure you're marking where the domain would start and not going beyond that point. So it starts here and then it can go anywhere below. All right, last one. Again, we start with the original 3 points. These are specific to these square root functions. Every type of parent function has its own original points. Okay, transformation x plus 2 means I do the opposite and I subtract 2 from my x values. Okay, and then nothing here to multiply. I'm just going to subtract 4 from my y values. So subtract 4 from all the y values. So those are my new points. Okay, so I have the point -2, -4. Right there. That's the starting point. We don't go beyond that. -1, -3, and 2, -2. Okay, so this is the starting point. Pay attention to the sign. I have greater than or equal to. That means 2 things. It's going to be a solid line, and the greater than means it's going to be shaded above. Okay, so sketch in a solid line like that in the shape of a curve, and then make sure when you go to shade above that you are marking the domain. We will never go beyond that point, so we can just shade from there.